Hi everyone, this is Zulfia from Sri Venkateswara College of Engineering. Today we are going to discuss about geometric transformation in 3D. From the course code of 21 CS62, the subject is cgip. So moving to the introduction. Introduction to geometric transformations in 3D. Geometric transformations are fundamental to 3D graphs. They allow us to manipulate and position objects in a virtual environment, creating realistic and engaging the experience. Applying transformation to 2, 3D objects, translation, rotations, and scaling. These are the three important 3D transformations used in the objects. Translation is like moving an object along a specific vector in 3D space. It alters its position, but it not its orientation. So moving to the rotation an object around a specific axis, changing its orientation in 3D space while preserving its position. And what is scaling? Scaling is like enlarging or shrinking an object uniformly or non-uniformly in all three dimensions, affecting its size but not its position or orientation. Next is synchronizing transformations on multiple objects. So in this, coordinate systems, transformation matrix, and synchronizations are the three multiple things or transformations used in the synchronizing for the object or a 3D object or a 2D object. So coordinate systems, each object has its own coordinate system, which is crucial for applying transformations accurately. Transformation matrix, a matrix that encodes all the transformations applied to an object, making it easy to apply them in sequence. Synchronization. Synchronization. Okay, moving to the synchronization, applying transformations to multiple objects simultaneously by referencing their respective coordinate systems and sharing transformation matrix. So in synchronizations, the transformation on multiple objects are with these three steps: coordinate systems, transformation matrix, and synchronization. Next is techniques for simultaneous transformations. What all techniques we are using for the simultaneous transformation for the object moving or which the object we want to be with the dimensions and all. So hierarchical structure, constraint systems, and animation systems, and inverse kinematics. So these are the four techniques we are using simultaneously in the transformation. So moving to the hierarchical structure, organizing objects in a tree like hierarchical, where transformations applied to parent nodes affect all the child nodes. It's like when we are organizing any object like in a which is in a tree like structure, the transformations are applied to the parent node, and that is going to affect all the child nodes, and it will be like whatever the parent nodes is going to perform, same thing will be done by child nodes, because of once if we are just forcing one node, it will be connected to the all node. This is the hierarchical structure technique done in the transformation. Then is constraint systems, so defining relationship between objects, ensuring they move and rotate together based on specific rules or constraints. So defining relationship between the objects, ensuring they move and rotate together based on specific rules and constraints. Like if we are moving, if you are trying to move or rotate, if you are trying to rotate or move an object, we can only rotate it with the whole thing, like we can only rotate the whole body. It is not like we are only rotating the only a single edge, we are rotating the whole body. So here we are defining the relationship between this object. If one of the edge is rotating, then the opposite edge should be rotated. It ensures this move, like if it is rotating the first edge, the simultaneously the second or third or fourth edge will be also rotated. It is having a relationship between the two edges or two objects or like that, which will be performed with the specific rules or constraints in this method. So animation systems using keyframing or procedural animation, techniques to define how transformations change over time, creating dynamic and smooth transition. In animation system, using keyframes or procedural animation techniques to define how transformations change over time, creating dynamic and smooth transition. Like keyframes are like the number of keyframes are present, the more the actual object will be showed. Like any animation techniques will be done with the framing, so it will define how the transformation change over the time, creating dynamic and smooth transition. So next is inverse kinematics. So a technique that allows you to control the position of objects and affects the position of all the other parts. A technique which control the position. If one side of the position is controlled, then the other side of the positions will be simultaneously controlled. It is like all similar like hierarchical structure. One part is affected, the other part will be automatic affected, and it will be same, they follow the same thing which is done for the first one. Like if one position is moving, then the rest of the positions will move. So if some positions will be affected, then all the other position get affected. Next is challenge and consideration. So computational complexity, performance optimization, visual fidelity, user experience. Computational complexity is nothing but simultaneously transforming the multiple objects can be computationally demanding, especially for large scenes or complex objects. Like any object which is simultaneously transforming the multiple objects can be computationally demanding, especially large science or complex objects. For performance optimization is techniques like caching, spatial partitioning, and optimized algorithms are essential for the maintaining real-time performance like that. Visual fidelities, ensuring smooth and realistic transformations require careful attention to details such as interpolation, easing function, and collision detection. User experience of providing intuitive and responsive controls for manipulating multiple objects simultaneously is crucial for a good user experience. Next is practical applications and use cases. Animation creating realistic movements and interaction between multiple characters in animated films and games. This is an open example that we are seeing this in the TVs and all. This is an open example that we can see animations how these characters have the interaction between the one and another animation. I mean, in the animation, how the characters are interacting with each other. Game development enhancing gameplay by allowing players to interact with and manipulate the multiple objects in a virtual environment. In virtual environment is nothing but we can feel it like that it is happening with us, but it is in a virtual environment. It is just an imaginary environment where we are standing or we are experiencing about it. Product design is visualizing and manipulating 3D models of project to optimize their designs. Then is the architecture. Thank you.